Hello everyone and welcome back to the GCSE Maths series. Today we're going to be looking at direct and inverse proportion. So let's get straight into it. So first of all, we're going to start off with direct proportion. Two things are directly proportional if when one thing gets bigger, the other one gets bigger by the same amount. So they increase with each other. So if one was to double, the other factor would double. If one factor was to half, the other factor would also half. So an example that I've come up with is when you work 10 hours, you will get paid 120. When you work 20 hours, you will get paid 240. Hence, hours and pay are directly proportional because as one increases by a rate, so in this case is doubling, the other factor increases by the same amount. It also doubles. So, a bit of notation that we learn is that when two factors are said in a question, they don't always mention that it's directly proportional or inversely proportional. We just have to realize by looking at the question, okay, so they're going up by the same amount, two different factors, hence we can call them directly proportional. And when two factors are directly proportional, we use a notation like this. And this is event 1 or factor 1, and this is event 2. We can then create a formula or an equation where we have y equals to kx. And k in this case is a constant at which they both change. And in this case, the constant would be hourly pay because that is the constant from 10 hours to 20 hours, while you get paid more at 20 hours. It is the hourly pay which stays constant, times is through, and make sure you earn double. Okay, moving on to some directly proportional questions. So it tells us that a car travels at 60 miles. A car travels 60 miles in 1.5 hours. So the two events are miles, which we'll call x, and hours, which we'll call y, at a constant speed. And this is obviously going to be our k. How far will it travel in 4 hours? Okay, if it was to travel at the same speed. Okay, so now we set up our first equation. So we say x is directly proportional to y, and x equals to ky, something that we looked at previously, but yeah, okay. So now we fill in our numbers that we know. So we say that 60 is equal to 1.5 k. So now to solve for k, to work out our constant speed in this case, we do both sides divided by 1.5. As you can see, the 1.5s will cancel out, leaving a 1 because it's just the same number over the same number. 60 divided by 1.5, if you use your calculator, so 60 divided by 1.5 is 40. So 40 is our k, our constant speed. Now, setting up the new equation, we have that the new y is 4 hours. So x is equal to k y, and in this case our k is 40 times by our new y is our 4. So we know that in 4 hours, if they would travel at the same speed, because they're directly proportional, x will be 160 miles. Okay, moving on to the second question. A recipe uses 3 cups of flour. This is our x in this case. And 12 cookies is our y. So 3 cups of flour to bake 12 cookies. How many cups of flour are needed to bake 30 cookies? So this is obviously again going to be our constant because it tells us that 3 cups of flour is needed to bake 12 cookies. If we were to bake, say, 24 cookies, we would need double the amount of flour, so 6 cups, and that is just intuition that we're using. So now we can set up our directly proportional equation. So we can say x is directly proportional to y, meaning x is equal to ky. And ky and yk exactly the same. Hence, as you saw in the previous example, I switched it around just for mathematical sense. It looks better on the eye. So how many cups of flour are needed to bake 30 cookies, sorry. Looking at this, we first need to fill in what we know. So 3 is equal to k times by our 12. Rearranging this to make k the subject and solve for k. K is equal to 12 over 3. And obviously, you guys might be thinking, surely it should be 3 over 12 is equal to k. Yeah, so 3 over 12. Either way, from left to right or right to left, as long as k is the subject and alone by itself on one side of the equation, is perfectly fine. I just like to write it in this way because I like to read from left to right, but this is completely valid as well. So k is equal to 3/12, which is equal to 1/4. So setting up our new equation, we have x is equal to ky. Once again, our x is what we're trying to work out, our cups of flour, so we leave it as x as our unknown. K is still 1/4, times by our y is 12. So, sorry, our new y is 30. So our new x is 1/4 times by 30. So 1/4 times by 30 gives us 7.5 cups. Okay, moving on to inverse proportion. This is when two quantities uh, increase and decrease in opposite way. So a better definition is that two things or two factors are inversely proportional if one thing gets bigger and the other one gets smaller, but the product remains the same. So if one doubles, the other one halves. If one is multiplied by 3, the other is divided by 3. So, a real world example would be 6 workers can complete a job in 8 days. How long will it take? It will take 3 workers, less time obviously, to complete the same job. So, let's see, I haven't filled in the answer here. So, 6 workers is our x, and this is going to be our y. So when x is inversely proportional to y, we say x is directly proportional to 1 over y. Or, yeah, and then x is equal to k over y. And in this case, our x is 6, so 6 is equal to k over 8. Right? Hence, our k is equal to 48. Now, we have our new x, so we can write that as 3 is equal to k over, and in this case our k is 48, as we know, and we need to work out our y. So the way we do this is we times through on y on both sides, so times by y, and we get 3y is equal to 48, because this y and this y will cancel out to give 1. Then divide through by 3 on both sides, and we get y is equal to 16 days. And this makes logical sense because in the first case, we had more workers to complete the same job. They took 8 days. We then made it 3 workers, so lesser people, less labor, meaning there's less manpower. And now it's going to take 16 days. Like as you can see, as one decreased, as in workers, the amount of days taken to complete the job increased to 16. Hence, the two factors were inversely proportional. They work in inverse to each other. Looking at some more questions, a car travels a fixed distance. If the speed is 40 kilometers an hour, we'll make that our x. It takes 5 hours, we'll make that our y. How long will it take if the speed increases to 50 kilometers per hour? As you can see, this is not constant, so it's increased. So we need to see our first equation is x is equal to k over y when x is 40, and this is k over 5, making k equal to 200. How long will it take if the speed increases to 50 kilometers per hour? Then, using this equation again, we can say that 50 is our new x, is equal to k, which is 200 in this case, over our y. To work out our new y, we times through by y on both sides to get 50y is equal to 200. Then dividing through by 50, we get y is equal to 4. So y is equal to 4 hours. And as you can see, as the speed increases to 50 kilometers an hour, the time taken decreases from 5 to 4. Hence, they are inversely proportional, and we can see why we used the inverse proportional formula. Looking at question 2, a team of 5 workers, so 5 is going to be our x, can build a wall in 10 hours, that's going to be our y. How long will it take a team of 8 workers, that's our new x, to build the same wall assuming they work at the same rate. So you can use your intuition and say, okay, the amount of workers are changing, so surely the amount of time taken is also going to change because they're told they work at the same rate. So if you had 5 people working on a job compared to 8 people, you'd expect the time taken to go down. Hence, we can use the inversely proportional formula, as you know they're not going to both increase at the same rate. So x is equal to k over y. Then we're going to say 5 is equal to k over 10 to work out our k. In this case, k is our 50 because we times through by 5, by 10 on both sides, sorry. Then setting up our new equation with our new x, we say that 8 is equal to 50 over y, making our new y 50 divided by 8, which is equal to 6.25 hours. And this shows how this equation was inversely proportional, because as the workers went up, the time taken went down, which makes complete logical sense if we were to think about it outside of the question. Okay, that's going to conclude today's video on direct and inverse proportion. I hope you guys enjoyed the video. First, I hope you learned something. And as always, please make sure to like, comment, and subscribe. And I'll catch you guys in the next video in the series. Peace.